Hello everyone, myself Hans. Today we are going to solve the problem of radius of curvature. Here in the question, prove that the radius of curvature at any point t of the curve and the curve is given by x is equal to a 3 cos t minus of cos 3t and y is equal to a 3 sin t minus of sin 3t is 3a sin t. Let's solve the problem. Given curve is x is equal to a and 3 cos t minus of cos 3t. Let this equation 1, and the second curve is given by y is equal to a 3 sin t minus of sin 3t. Let this equation 2, and further differentiating equation 1 with respect to t, that is given by dx upon dt is equal to a is constant here, cos t differentiating with respect to t, this is given minus of sin t, this is minus of 3 sin t and minus of cos 3t. Differentiating cos 3t, minus is already present here once again, minus is already present, and cos 3 differentiating with respect to t, this is given by minus of sin 3t, and again 3t differentiating with respect to t, this is given by 3. Further we have to solve. This is given by dx upon dt is equal to a, and here is minus of 3 sin t, and here is minus is plus, this is given by plus of 3 sin 3t. Further we have to find differentiating equation 2 with respect to t, and this is given by dy upon dt is equal to, here is a is taking constant and 3 and sin t differentiating with respect to t, this is given by cos t minus, here is minus of sin 3t differentiating with respect to t, this is given cos 3t, and again 3t differentiating with respect to t given by 3. We have to write here, that is the value of dy upon dt is a 3 cos t minus of 3 cos 3t, and the value of dx upon dt is given by, we can also write that is a and 3 sin 3t minus of 3. Once again we have to take common from here 3, once again taking common from here 3, this is given by dx upon dt is equal to 3 is taking common, and here is sin 3t minus of sin t, and the value of dy upon dt, we can also take common from here 3, that is 3a, and this is given by cos t minus of cos 3t, and we have to find the radius of curvature, and radius of curvature is given by 1 plus of dy upon dx का होल स्क्वायर की होल पावर 3/2 upon d2y upon dx2, and we have to find the value of dy by dx, and dy by dx is given by dy upon dt upon dx upon dt. When we have to write, this is given by dy upon dt, and we can write dt upon dx, and dt to this is cancelled out, we get dy upon dx. So we can write dy by dx is dy upon dt upon dx upon dt, and so we have to put the value here. Dy upon dt, dy upon dt is given by 3a and cos t minus of cos 3t, dx upon dt is given by 3a 3a sin 3t minus of sin t, and from here 3a to 3 is cancelled out, and the value of dy by dx is dy upon dx is given by cos t minus of cos 3t upon here is sin 3t minus of sin t, and further we have to find the value of d2y upon dx2. So we have to differentiate. Let this equation third. Differentiating equation third. Differentiating once again. We can also modify the equation third. We can using the formula cos c minus of cos d, that is cos c minus of cos d is written as 2 sin c plus d by 2 and sin d minus c by 2, and you can also use sin c minus sin d formula. This is given by sin c minus of sin d is given by sin d, this is given by 2 cos c plus d by 2 and sin c minus d by 2, and we have to use two formula to simplify the dy by dx. Once again, this is given by dy upon dx, and we have to using the formula here cos c minus of cos d. This is written as 2 sin c plus d. Here is angle is t plus 3t. This is 4t, and 4t upon 2 is 2t. Again sin d minus c. Here is the angle is d is here 3 and 3t minus of t, that is 2t, and 2t divided 2, that is given by t upon, again we have to use sin c minus of sin d, and sin c minus of sin d given by 2 cos c plus d. Here is 3 plus 1 is 4t upon 2, that is 2t, and here is sin c minus d, 3t minus of t is 2t, and 2t upon 2 is t, only t, and from here sin t to sin t is cancelled out, 2 to 2 is cancelled out, and the remaining is here sin 2t upon cos 2t is tan 2t. Further we have to find d2y upon dx2. This is given by d2y upon dx2. This is tan 2 differentiating. This is sec square 2t, and again differentiating 2t with respect to t, that is given by 2. This is given by 2 sec square 2t, the value of d2y upon dx2. We have to put here radius of curvature is equal to 1 plus of dy by dx. Dy by dx is given by tan 2t. This is given by tan square 2t की whole power 3 by 2, and d2y upon dx2 is given by 2 sec square 2t, and further we have to solve. This is radius of curvature. 1 plus of tan square 2t is given by sec square 2t. This is given by sec square 2t की whole power 3 by 2 upon 2 sec square 2t. Once again when we have to differentiate here, tan 2t. This is sec square 2t, again 2t, 2 sec. Here we have to put here, that is 2 sec square 2t, and we have to take in from outside 3 by 2. We get from here that is sec qt, sec cube 2t. One second, sec cube 2t upon here is 2 sec square 2t, and we have to cancel out the terms, that is given by rho sec square 2t to sec cube is given by this 2, and this is sec 2t, and we have to find the value of, proved that the radius of curvature at any point of the curve is 3a sin t. Once again, 3a sin t. From here we have to put the value of cos c minus of cos t is given by sin c plus d by 2t, and sin c minus d by 2, sin c minus, one second, 2 sin c plus d by 2 sin d minus c by 2, and this is given by 3t minus of t. This is 2t by 2, this is sin t. Again we have to use 2 cos c plus d by 2 and cos sin c minus d by 2. Here 2 is cancelled out, sin 2t upon cos 2t, this is given tan 2t, and we have to differentiate. One second, here we have to, some mistake here, when we have to find d2y upon dx2, here tan 2 differentiating with respect to t, this is given by sec square 2t, and again 2t differentiating with respect to t, we get 2, and here is dx upon dt, and we have to put here dx upon dt. Once again, dt upon dx, sorry, here we have to put dt upon dx, and again we have to put here d2y upon dx2 in place of 2 sec square 2t into, we have to put dt upon dx, and we have to find the value of dt upon dx is, once again, dt upon dx is given by 1 upon of, here is dx upon dt is given by, once again, we have to calculate dx upon dt is 3a sin 3t minus of sin t, and we have to put the value of dt upon dx, so we have to write here 1 upon 3a, and this is given by sin 3t minus of sin t, and we have to put the value of sin 3t dt upon dx. We have to put the value of here, that is, this is given by 3a sin 3t minus of sin t, and this is given by sec square 2t. Once again, from here this is given by sec square 2t to 2t is cancelled out, and the remaining is here multiplication with 3, and we have to multiply here, that is given by 3a and sin 3t minus of sin t, and we have to use the formula again, sin c minus sin d here. This is given by rho radius of curvature is equal to, here is 1 upon 6a, and this is given by sec 2t upon we have to write here sin c minus of sin d. This is given by 2 cos c plus d by 2. 2 cos c plus d by 2, that is given 3t plus 1 t is 4t, and 4t upon 2, this is given by 2t, and sin c minus d by 2, this is given by 3t minus of t, that is 2t upon 2 is t. And from here we can also write, once again, 3a sin t, sin c minus of sin d, we have to put here once again dy by dx is given by 10 2t, and this is given by 1 plus of 10 square 2t. 10 square 2t is given by sec square 2t, and sec square 2t, this is sec cube 2t, and in the denominator d2y upon dx2 by 2t into 3a sin 3t minus t, this is given 1 by 6a, 1 by 6a. Once again, we use the formula right or wrong, once again we have to check. We have to solve the given problem. Given curve is x is equal to A 3 cos t minus of cos 3t. Let this be question 1, and the second curve is given by y is equal to a 3 sin t minus of sin 3t. Let this equation 2, and differentiating equation 1 and 2 with respect to t. First we have to differentiate equation 1. This is given by dx upon dt, and this is a, and 3 differentiating cos t with respect to t. This is given by minus of sin t, and minus of cos 3t differentiating with respect to t. This is given by minus of, we use the minus of sin 3t, and again 3t differentiating with respect to t. This is given by 3, and we can also write this is given by a, this is given by minus of 3 sin t, and here is minus is plus, minus of minus is plus, this is plus of 3 sin 3t, and from here we can also write the value of dx upon dt. Dt is given by minus 3 is taken common from bracket, and a is already present, and we can write this is given by sin 3t minus of sin t. This is the value of dx upon dt, and further we have to differentiate equation 2 with respect to t. This is given by dy upon dt is equal to a is taken to outside, and sin t differentiating with respect to t. This is given by cos t, and minus of here sin 3t differentiating with respect to t. This is given by cos 3t, and again 3t differentiating with respect to t. This is given by 3, and we can write here, and from you can also take a common from here dy upon dt, taking 3 common. This is given by 3a, and cos t minus of cos 3t, and further radius of curvature is given by rho is equal to 1 plus of dy by dx का whole square की whole power 3 by 2 upon d2y upon dx2. We have to find first dy by dx, and then we have to find d2y upon dx2. First we have to find dy upon dx, and dy upon dx is written as dy upon dt upon dx upon dt, and so we have to put the value of dy upon dt. Here dy upon dt is given by 3a cos t minus of cos 3t, cos t minus of cos 3t upon, and dx upon dt is given by 3a sin 3t minus of sin t, and from here 3a to 3a is cancelled out, and this is given by dy upon dx is equal to cos t minus of cos 3t upon sin 3t minus of sin t, and using the formula to simplify the given terms cos c minus of cos t and sin c minus of sin t. We know that cos c minus of cos t is written as cos c minus of cos d is written as 2 sin c plus d by 2 and sin d minus c by 2, and sin c minus sin d, sin c minus of sin d is written as 2 cos c plus d by 2 and sine c minus d by 2. Further we have to use the formula here. This is given by dy upon dx is equal to, here is in place of c is t and in place of d we have to here 3t. So we have to write 2 sine c plus d here. T plus 3t is 4t. 40 upon 2 is 2t. This is sine 2t. And further into sine d minus c. Here d is 3t. 3t minus of t is 2t. 2t upon 2 is only t. This is given by sine t upon. Further we have to use sine c minus of sine d. This is given by 2 cos c plus d. Here 3t plus t is 40. 40 upon 2 is 2t. And further sine c minus of d. Sine c minus of d. That is 3t minus of t. This is 2t and 2t upon 2 is t. And from here sin t to sin t is cancelled out and 2 to 2 is also cancelled out. And the value of dy by dx is written as tan 2t. Further we have to find the value of d2y upon dx2. d2y upon dx2 and this is written as d by dx of dy upon dx, and we in the form of we can also write here, that is once again d by dx of. So then dy by dx is also written once again. We have to put the value here, that is d by dx of, put the value of dy by dx here, that is tan 2t. Tan 2t. And differentiating here, this is given by y upon dx2. Differentiating tan 2 with respect to x, this is given by sec square 2t. Sec square 2t. And again 2t differentiating with respect to t, this is given by 2 and dt upon dx. And we have to put here the value of dt upon dx. This is given by 2 sec square 2t into, we have to put dt upon dx. We have to find dt upon dx is here. This is given by dt upon dx 1 upon 3a, 1 upon 3a and sine 3t, sine 3t minus of sine t. Again we have to use the formula of sine c minus of sine d, and we can also write here, that is 2 sec square 2t into 1 upon, we have to use here 1 upon 3a. We can also 3a is taken into our side, 3a, and we have to use sin c minus of sin d formula here. This is given by 2 cos c plus d by 2. 2 cos c plus d by 2. This is 3t plus t is 40 and 40 upon 2 is, that is once again sin c plus d by 2. This is given by 3t plus t is 40 and 40 divided 2 is 2t. This is 2 cos t and sin c minus d by 2. 3t minus of t is 2t and divided by 2. This is given by sin t. Further we have to write once again. Further we have to write, this is given by d2y upon dx2 is equal to, here is, from here 2 to 2 is cancelled out and the remaining is sec square 2t upon 3a into, here is cos 2t, once again cos cos 2t into sin t, and we have to put here put in the value of dy by dx and d2y upon dx2 in the radius of curvature. This is given by rho and 1 plus of dy by dx. Dy by dx is given by tan 2t and square of dy by dx. This is given by tan square 2t and whole power 3 by 2 upon, we have to write d2y upon dx2. Here is given by sec square 2t upon 3a cos 2t into sin t, and further we have to write, this is given by 1 plus of sin square t is sec square 2t. This is given by sec square 2t का whole power 3 by 2, and from here this is given by sec square 2t into, this is 3a cos 2t into sin t, and further we have to solve. We can also write radius of curvature is equal to, here we have to sec square 2t multiply with the power 3 by 2. This is given by sec t power 3 2t upon, here is sec square 2t into 3a cos 2t into sin t, and from here sec square 2t to sec cube 2t is cancelled out, and here remaining is sec 2t, and we can also sec 2t is taken into denominator. This is given by 1 upon cos 2t into, here is 3a cos 2t into sin t, and from here cos 2t to cos 2t is cancelled out, and the remaining is, so curvature is equal to 3a sin t. This is the required solution of the given problem. Thank you class, and thank you for watching.